What if the universe has begun to answer us not with distant radio whispers, but with bodies of stone and ice, crossing into our skies like uninvited guests? From the blackest reaches of interstellar space, something arrives. It does not roar, it does not burn. No thunder marks its entry. It drifts silently into the solar system, a dim point of light against the crowded tapestry of stars. To most eyes, it would seem like nothing at all. Yet within that faint glow lies the weight of an ancient journey, a messenger shaped in alien sunfields far beyond the reach of human memory. Astronomers have named it 3I Atlas. To the night sky, it is a fragment. To human imagination, it is a question without an answer. It came from the abyss, and unlike the countless comets that circle our own star, this one carries the signature of another home. Its path, its velocity, its quiet defiance of the sun's pull mark it as a traveler from elsewhere. And here the wonder deepens. For centuries, humanity has searched the skies, sending signals into the dark, chasing echoes of life across the void. Yet what if we have summoned something different? What if our endless curiosity has not drawn voices but objects, flung loose from forgotten systems, drifting until they find us? Is 3I Atlas merely a shard of ancient rock, a relic of a shattered world wandering endlessly until chance brought it here? Or is it something stranger, an answer shaped not in words but in presence? The universe remains silent, yet it places questions in our path, and sometimes those questions arrive as light among the stars. In the quiet of December 2019, the skies above Hawaii were being watched by a sentinel of glass and mirrors. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, was built to serve as a guardian, scanning the heavens for near-Earth objects that might one day threaten the planet. Its twin telescopes swept across the dark, not seeking mystery but safety. Yet on one of those nights, they captured a glimmer that belonged to neither routine comet nor familiar asteroid. The light was faint, almost forgettable, a small trace against the deep field of stars. At first glance, it seemed like any other fragment drifting within the solar system. But the orbit was wrong. Its speed was unsettling. The track it carved against the background sky suggested that this visitor did not belong to the sun's domain. It was coming from elsewhere, from the abyss between the stars. The discovery would soon be catalogued as 3I Atlas, the third recognized interstellar object to ever cross human instruments. The first had been 1I Oumuamua, cited in 2017 as a thin, tumbling enigma that left astronomers with more questions than answers. The second, 2I Borisov, followed in 2019, its comet-like tail more familiar yet still otherworldly, its ices born beneath an alien sun. And then, as if the universe had resolved to remind humanity of its wider stage, came Atlas. Astronomers were cautious at first. Its brightness did not behave as expected. Its apparent fading and disintegration hinted at fragility. Some wondered if it might vanish before it could be studied in depth. Yet its trajectory was clear, a path that cut through the solar system at speeds no bound comet could achieve. More than 60 kilometers per second relative to the sun. Such a velocity revealed its origin beyond Neptune's reach, beyond even the Oort cloud, marking it as a true interstellar wanderer. Among the scientists who first analyzed it were observers attuned to the subtleties of motion and light. Their task was not only to measure, but to interpret what kind of fragment could survive the gulf of interstellar space. The data revealed an object stretched and fractured, likely a remnant of a once larger body. Unlike Oumuamua, whose shape and reflectivity led to debates about artificial origins, Atlas seemed more fragile, less like a messenger and more like a shard from a distant catastrophe. Yet fragility carries its own message. For every intact world circling alien stars, there are countless broken pieces cast loose by gravity, by collision, by time. Atlas was one of these, a reminder that the universe is littered with wreckage as much as with worlds. Its arrival in 2019 tied humanity to that larger cycle, the endless scattering of matter from star to star. The astronomers in Hawaii had set out to guard against local threats. Instead, they had opened a doorway to the cosmic beyond. The faint light they recorded was not a warning of danger, but of perspective. Earth was no longer merely observing its own family of comets and asteroids. It was glimpsing the debris of other suns, fragments carried across unimaginable distances, now burning briefly in human awareness. In that moment, The solar system was no longer an isolated stage. It was part of a vast and ongoing conversation, one written in orbits and in silence. Atlas was the third voice in that dialogue, the latest question to enter from the darkness beyond. The realization came not from brightness or from form but from motion. When astronomers traced the path of 3I Atlas across the sky, they saw something that could not be mistaken. Its orbit was not closed. It did not bend into an ellipse like the comets born of the Oort cloud, nor did it obey the long arcs of asteroids chained to the sun's dominion. Instead, it followed a hyperbolic course, the unmistakable fingerprint of an interstellar traveler. A hyperbola is the geometry of escape. It means the object was never bound to this star and never will be. 3I Atlas had approached, swung briefly through the inner solar system, and was already on its way out, destined to return to the darkness from which it came. The velocity told the same story. Even as the sun pulled at it with all its gravity, the object moved too quickly, more than 60 kilometers per second relative to the sun, far beyond the speed any native comet could maintain. No matter what the solar system demanded, Atlas would not be held. This revelation carried weight. Only 2 years earlier, the discovery of Oumuamua had stunned the world. That elongated enigma had been the first proof that interstellar fragments could cross paths with Earth's telescopes. Before then, such wanderers were only theory, calculated as statistical probabilities in the chaos of galactic dynamics. Oumuamua was supposed to be a once-in-a-century event, if not rarer. Yet here was another arriving almost immediately after. The shock reverberated through the scientific community. Had astronomers underestimated the openness of the cosmos? Were such visitors common, passing unnoticed through the centuries until human instruments grew sharp enough to catch them? Or was the solar system living through an unusual moment in galactic history, a stream of debris flowing through its orbit around the Milky Way? The contrast with Oumuamua deepened the mystery. Where Oumuamua was solid and stubborn, reflecting sunlight in ways that defied easy explanation, Atlas was fragile. Within weeks of its discovery, it began to disintegrate, its nucleus fragmenting into smaller pieces under the heat of the sun. If Oumuamua was a riddle wrapped in stone, Atlas was a ghost unraveling before the eyes of astronomers. Two messengers so different in character, yet bound by the same revelation they did not belong to this system. The emotional impact was profound. Humanity had always imagined the solar system as a kind of sanctuary, bounded by the gravity of its central star. Now that boundary seemed more porous than ever. The vast distances between stars were not impenetrable walls but shifting currents, carrying fragments across light years until they spilled into the sun's realm. In the silence of those discoveries, a philosophical unease took root. If matter from alien systems could find its way here so easily, then the cosmos was not a closed stage but an open corridor. Earth was no longer an island. It was part of a sea, its shores brushed by drifters from forgotten worlds. The sun was not a solitary beacon, but one star among billions exchanging fragments with its neighbors in ways only now being seen. The orbit of 3I Atlas was more than a line on a chart. It was a reminder that the solar system itself is not separate, but porous, vulnerable to the touch of the unknown. What had once been theoretical became undeniable. Interstellar wanderers exist, and they are finding their way to us. And with that realization, the universe felt closer, stranger, and infinitely more alive. The first detection was only the beginning. Once 3I Atlas was confirmed as interstellar, astronomers around the world turned their attention toward it, racing against time. The object was faint, fragile, and vanishing fast. Every hour of observation mattered. Every telescope became a lens into a fleeting encounter with something that had traveled for millions of years to reach the solar system. Ground-based telescopes in Hawaii, Chile, and Spain joined the effort. The Pan-STARRS facility, already famed for its discovery of Oumuamua, recorded its glow against the stellar background. The Gran Telescopio Canarias, one of the most powerful in the world, gathered what little light could be collected from this faint, wandering fragment. Each image was a struggle. Atlas shone at magnitude so dim that even the most sensitive detectors strained to resolve it. To the naked eye, it would have been invisible, just another thread of shadow against the night sky. The faintness was a clue as much as an obstacle. It suggested the object was small, perhaps no larger than a few hundred meters across. It hinted at fragility, at a body not dense and rocky like an asteroid but more porous, a mixture of dust and ice that sunlight could easily unravel. Indeed, as the days passed, Atlas began to break apart. Its nucleus splintered, the glow of its coma spreading as fragments drifted away. Unlike the durable path of Oumuamua, this interstellar guest was dissolving before humanity's eyes. Rotation offered another puzzle. As the light curve was measured, tiny fluctuations in brightness caused by its spin, astronomers sought to model its shape. The data was uneven, corrupted by the object's disintegration, yet some patterns emerged. Atlas seemed irregular, tumbling, never still. It spun in ways that suggested prior trauma, perhaps a collision long ago in another star system, or tidal stresses from a violent ejection. Its spin told the story of violence, of an object cast out into interstellar exile. Spectral data was even harder to obtain. By dispersing the light into its component wavelengths, scientists could search for the fingerprints of molecules, for the telltale signs of water ice, carbon monoxide, or silicate dust. The results were meager, blurred by the faintness and by the object's disintegration. Still, there were whispers in the data, traces consistent with ices sublimating under the sun's heat, hints of carbon-rich material. Atlas, it seemed, was more comet than asteroid, a body shaped in the icy outskirts of a distant solar system, where volatiles could freeze in abundance. But where had it come from? That question opened a labyrinth of models, simulations, and speculation. Some astronomers suggested it had been born in the distant reaches of a binary star system. In such environments, gravitational chaos can eject comets into interstellar space at high velocities. If Atlas had once circled a binary pair, then its exile was the natural product of celestial mechanics, a slingshot into the void. Others proposed a more catastrophic origin. Perhaps it was the fragment of a shattered exoplanet, torn apart in a collision as violent as those that once shaped Earth's own moon. If so, Atlas was more than a comet. It was a shard of an alien world, carrying within it the chemistry of another planetary system. Its dust might contain minerals born under a different sun, forged in conditions humanity has never seen. Still others leaned toward the simpler model, that Atlas was once an ordinary comet circling a distant star. Billions of years ago it could have been nudged by a passing giant, flung out of its native system and left to drift. For eons it wandered the dark, a frozen relic until it chanced upon the pull of our sun. Each hypothesis carried weight. Each was incomplete. With so little data, no single origin could be confirmed. The object was fading too quickly. By the time major telescopes gathered their strength, Atlas had already begun to disintegrate, its nucleus unraveling under the sun's warmth. The very act of approaching our star was erasing the evidence of its birth. The puzzle would remain half-solved, a riddle broken apart before it could be read. Yet even in fragments it offered glimpses of the vast. To detect any interstellar body at all is rare beyond measure. The Milky Way may contain countless comets and shards drifting between stars, yet the chance alignment required for one to pass close enough to be seen is extraordinary. Oumuamua in 2017 was the first. Atlas only 2 years later was the third. The probability defied expectation. Some astronomers began to wonder whether interstellar objects were far more common than anyone had imagined. If so, then every nearby star might be shedding fragments into the void, seeding the galaxy with debris. The solar system would not be a closed world, but a crossroads of trajectories, a place where foreign bodies arrive unbidden. Atlas, in its faintness and fragility, was proof of this hidden traffic. It was a messenger not of intent but of inevitability, the inevitable mixing of matter between stars. For those watching, the emotional weight was undeniable. Each observation carried the knowledge that the opportunity would not come again. The object was fading, its fragments dispersing into invisibility. No spacecraft would reach it in time. No laboratory sample would be returned. The data would remain partial, the story unfinished. Humanity had been granted only a fleeting glimpse of something vast, and then it was gone. The investigators pressed on, turning to computer simulations, tracing the hyperbolic trajectory backward through time. They could not identify its precise origin. Its path had been perturbed by the gravity of Jupiter and by countless subtle influences. Yet they could rule out the nearby stars. Atlas had not come from Alpha Centauri or any other neighbor. It had traveled far longer, its journey spanning millions, perhaps tens of millions of years. The exact star from which it had been cast was lost in the fog of galactic motion. That uncertainty deepened the mystery. Atlas was not only alien in substance, it was anonymous. It came without a name, without a known parent star. It arrived from the general abyss, a messenger with no return address. Humanity could only guess at its birthplace, reconstructing possibilities from fragments of light. And so the deeper the investigation went, the larger the unknown became. Every measurement opened further questions. Was its fragility typical of interstellar debris, or had humanity simply chanced upon a rare dissolving example? Did its chemistry reflect the common fabric of the galaxy, or the unique history of a lost world? Was its presence evidence that the galaxy is thick with wandering comets? Or was it a statistical fluke, a coincidence of timing? In the end, the investigation of Atlas revealed less about the object itself and more about the scale of ignorance humanity still carries. Telescopes could measure its fading light. Spectrographs could hint at its ices. Models could simulate possible ejections, but the answers remained incomplete. Atlas was a puzzle that dissolved in human hands, leaving only the outline of a larger truth. The galaxy is restless, porous, alive with exchange. It reminded astronomers that the solar system is not a sealed container. It is a crossroads of galactic motion, a place where strangers pass through, silent and unannounced. Each interstellar object is a letter carried across millions of years. But the handwriting is blurred, the message unfinished. As Atlas vanished into fragments, the deeper investigation closed with a sense of humility. Humanity had glimpsed the vast but could not hold it. A shard from another star had entered the solar system, offered its brief riddle, and dissolved back into darkness. The data would remain incomplete, the answers forever tentative, and yet the mystery itself carried value. The unanswered questions were not failures but invitations. They called humanity to build sharper instruments, to prepare for the next messenger, to listen more closely to the subtle voices carried by drifting worlds. For now, 3i Atlas was gone. But in its fleeting presence, it reminded the world that the cosmos is not distant. It is in motion, it is connected, and it is filled with stories yet untold. The more astronomers looked, the less certain they became. What began as a faint point of light had already defied expectation. Now, with each night of observation, the story of 3i Atlas grew stranger. Its brightness fluctuated unpredictably. Comets are expected to glow more strongly as they near the sun, their ices sublimating into luminous tails. Yet Atlas shimmered irregularly, sometimes dimming when it should have brightened, sometimes glowing in fits, as if its surface were peeling away in sudden bursts. The data revealed spikes and drops that resisted smooth modeling. It behaved like a candle in shifting winds, its light fragile and unstable. Then came the fragmentation. High-resolution images suggested the nucleus was breaking apart. Small companions trailed the main body, scattering like embers caught in a gust. The violence of its disintegration was unusual. Even fragile comets from the Oort cloud often survived their passage into the inner solar system, before unraveling near perihelion. Atlas seemed to fracture prematurely, as if it carried old wounds. Perhaps it had been cracked by collisions before leaving its native system. Perhaps the stress of interstellar travel had weakened its structure. Or perhaps the chemistry of its ices was stranger than expected, more volatile under the light of an alien star. Whatever the cause, the object was dying before astronomers could truly know it. The observational window, already brief, was collapsing faster than anticipated. Within months of its detection, the nucleus disintegrated so completely that only diffuse trails of dust remained. The interstellar traveler had slipped into the solar system and unraveled almost instantly, leaving only partial records. This left scientists in a state of speculation. With so few measurements, any conclusion was precarious. Was Atlas typical of interstellar objects, fragile and short-lived? Or was it an exception, a rare specimen caught in its final collapse? The incomplete data opened as many questions as it closed. And yet, the mystery was larger than the object itself. 2 interstellar visitors had now been observed within just a few years, Oumuamua in 2017 and Atlas in 2019. Probability alone suggested something unsettling. If humanity had noticed 2 in such quick succession, how many had passed unseen in centuries past? How many fragments of alien suns had drifted silently through the solar system? Too faint for naked eyes, too fleeting for primitive instruments. For most of human history, the sky was measured only in constellations, patterns of myth, and the slow dance of familiar planets. The technology to notice objects like Atlas is barely a generation old. If the heavens have always carried such wanderers, then Earth has lived under their silent passage without ever knowing. Some may have been visible for days or weeks in ancient skies, mistaken for omens or falling stars. Others may have slipped through in complete secrecy, invisible specks moving faster than any eye could track. The implications were unsettling. Astronomers began to calculate rates. If two had been caught so quickly, then interstellar objects might be entering the inner solar system every year, perhaps even every month. Most would be too small or too dim to detect, yet their numbers would be vast. The solar system, once imagined as isolated, seemed suddenly porous, crossed by a steady tide of alien debris. This thought brought a quiet unease. If fragments arrive so often, then Earth is not just a world in orbit around the sun. It is a world exposed to the galaxy, brushed by material that comes from elsewhere, carrying chemistries not native to this system. Every fragment is a potential messenger. Some are benign, wandering shards of rock and ice, but the sheer scale raises questions. Could larger bodies slip through unnoticed? Could unseen collisions have shaped the history of the planets? Already, models of planetary formation include the exchange of material between systems. A star cluster, rich in gravitational interactions, can scatter billions of objects into interstellar space. Some of them will pass through neighboring systems. Over billions of years, such exchanges may have seeded worlds with ingredients from alien suns. Perhaps even Earth carries in its crust the dust of other systems, delivered long before human eyes could witness the event. Atlas deepened that possibility. It was not just a curiosity, but a reminder that the solar system is part of a greater web, a galactic economy of matter in constant drift, and within that web, unseen forces may be at work. The planets themselves may be shaped not only by the gravity of the sun and the pull of nearby giants like Jupiter, but by encounters with interstellar debris. Each visitor leaves a trace, however faint, on the dynamic balance of the solar system. Some may even alter trajectories, seed impacts, or deposit volatiles that change the chemistry of worlds. This is what made the encounter with Atlas terrifying in its own quiet way. Not because the object threatened Earth. Its trajectory never approached danger, but because it revealed the scale of what goes unnoticed. If humanity has already witnessed two in such quick succession, then the sky must be far busier than previously imagined. The solar system is not a closed sanctuary. It is an open corridor, its boundaries soft and permeable, its history entangled with countless alien fragments. The mystery deepened with reflection. How many unseen visitors had come and gone before telescopes existed? How many impacts might have been caused by interstellar debris, their origins indistinguishable from native comets? Could the extinction events of Earth's past have been triggered not only by local bodies, but by fragments cast from other suns? The possibility cannot be excluded. The geological record holds scars that reveal impacts, but not the origin of the impactors. In those craters may lie the fingerprints of ancient interstellar wanderers. The case of Atlas offered no certainty. Its data was incomplete, its body shattered before it could be fully known. But in its incompleteness lay the shadow of something larger. Humanity does not merely live under the light of its own star. It lives within the flux of the galaxy, exposed to the wanderings of matter without allegiance. Each fragment is a reminder that the cosmos is not distant. It intrudes silently and without warning. And so, as Atlas faded into dust, the mystery did not close. It widened. The discovery left more questions than answers, more speculation than resolution. Its brief visit forced astronomers to reconsider the openness of the solar system, the frequency of interstellar debris, and the unseen forces that may shape planetary history. What makes the story unsettling is not the object itself, but the realization it embodies. If the galaxy sends fragments so freely, then Earth is not merely a planet in orbit. It is a receiver, a target, a participant in exchanges that stretch across light years. The barrier once thought to exist between stars is thinner than imagined. Atlas arrived faintly, dissolved quickly, and left almost nothing behind. Yet in its passing, it whispered a truth larger than its size. The solar system is porous. The cosmos is alive with motion, and the unseen may shape the world more profoundly than the seen. When the final fragments of 3I Atlas slipped into obscurity, what remained was not evidence but questions. With its body dissolved into dust and its light fading from telescopes, astronomers were left with the most human of tools: speculation. For in science, when data ends, theory begins. The leading hypothesis was the simplest and in many ways the most sobering. Atlas could have been a piece of natural debris, cast loose from a forming planetary system. Every young star is born amid chaos, its planets sculpted from disks of gas and dust, its comets hurled outward by the gravity of giants. Billions of fragments are lost in these early epochs, ejected into the abyss between suns. Atlas may have been one of them, a shard thrown out in the infancy of a distant system, wandering for millions of years before finding its way here. Others imagined a more violent birth. Around many stars, collisions are inevitable. Worlds form, collide, and sometimes shatter. Moons are torn free. Atmospheres are stripped away. The echoes of these catastrophes can last for billions of years. If Atlas was born of such violence, then it was more than a comet. It was a relic of a broken world, a survivor of impact carrying with it the chemistry of a place long gone. Each grain of dust in its trail might have been forged in a planetary crust beneath an alien sky. The question of its true nature remained unresolved. Was Atlas active, shedding gas and dust like a comet, or was it inert, a rocky fragment resembling an asteroid? The faintness of its light made certainty impossible. Some spectral signatures hinted at sublimating ices. Others suggested a more solid core. Its rapid fragmentation complicated the picture further, blurring the line between comet and rock. Perhaps it was both, a hybrid body once icy, now fractured into stony remnants. But beyond the natural models, speculation wandered further. Some scientists, quietly and cautiously, asked whether such objects might not always be accidental. Could interstellar civilizations, if they exist, ever send probes disguised as debris? The thought was not born of fantasy alone. Oumuamua had stirred similar debates. Its unusual acceleration, unexplained by visible outgassing, led some to wonder if it might be artificial. Atlas, by contrast, showed fragility and cometary behavior. Yet even so, the timing of two such visitors in such quick succession made imaginations restless. To consider such possibilities is to step into dangerous territory, where skepticism wars with wonder. The scientific method demands caution, demands natural explanations before extraordinary ones, yet humanity's mind is restless. The appearance of interstellar fragments invites the question, are these only rocks or are they signals? Is the galaxy littered only with the debris of shattered worlds, or could some pieces be designed? Messages flung across space not in radio waves, but in physical form. Another speculation carried echoes of ancient philosophy. Could Atlas be part of a process larger than discovery? Panspermia, the seeding of life across the stars? If comets in our own system carry organic molecules, frozen reservoirs of the chemistry of life, then so too might interstellar comets. In their journeys across light years, they could scatter these molecules into countless planetary systems. A billion years ago, such a fragment might have struck Earth, delivering amino acids or other precursors that nudged life toward its beginnings. If so, then Atlas was not merely a visitor. It was kin. Its dust may have contained the same molecules that once shaped the spark of life here. For many astronomers, such thoughts were unsettling. To see an interstellar object is to confront more than data. It is to confront the possibility that the universe is in dialogue, not in words, but in matter. Each visitor may be carrying more than rock and ice. It may be carrying memory, chemistry, possibility. The cosmos, then, is not silent. It is whispering across the stars through its debris. Yet scientists are cautious, often painfully so. For every imaginative leap, there is a voice pulling back, insisting on restraint. The known must take precedence over the unknown. It is safer to describe Atlas as a comet than as a probe. Safer to describe it as a shard of ice than as a vessel of life. The discipline of science is built on skepticism, on resisting the temptation of stories too vast to be proven. And yet, within the halls of research, the tension is real. The imagination strains against the leash of evidence, yearning to see in these fragments not only geology, but intent. The psychological weight of such encounters cannot be ignored. Humanity has always looked upward, wondering if it is alone. Interstellar visitors force that question closer. They remind us that other suns are not distant abstractions. They are connected, in ways material and tangible. A fragment of their history can pass into ours. And if fragments can arrive, then what else might follow? In the story of Atlas, the struggle was not only to collect light, but to balance wonder with discipline. Theories abounded: natural debris from binary stars, relics of shattered planets, icy messengers of panspermia, even whispers of civilizations. But the data remained too thin. Each possibility lingered like a shadow, present but unconfirmed. Still, the speculation itself was valuable. It expanded the imagination of science, reminding humanity that the cosmos is not a fixed backdrop but an active stage. Interstellar objects are no longer hypothetical. They are real. They are here. And if two have been seen in just a few years, there must be more, waiting to be noticed, waiting to be studied with sharper eyes and stronger instruments. In that light, Atlas becomes more than a failed investigation. It becomes an invitation to prepare for the next messenger, to imagine more boldly while measuring more carefully, to recognize that the line between natural and extraordinary is often thinner than it seems. For in every fragment lies a possibility, that it is stone or ice or life, that it is silence or signal, that it is chance or intent. Atlas carried no answers. It carried only the reminder that the universe is larger than certainty, and that speculation is not weakness but the beginning of discovery. And so, as its dust scattered into the solar wind, the theories multiplied, each one a reflection of humanity's dual nature, conservative in its methods, imaginative in its hopes, standing between skepticism and wonder, looking at a faint, dissolving light and asking, as it has always asked, what if? The story of Three-Eye Atlas did not end with its disintegration. In many ways, it began there. Its arrival, like that of Oumuamua before it, was less an answer and more a challenge. A fleeting glimpse of an interstellar messenger had shown what humanity could not yet do. The object was noticed too late. No spacecraft could reach it. No mission was ready to chase it. The data was thin, incomplete, unsatisfying. The cosmos had spoken, and the instruments of Earth were not yet prepared to listen. In the wake of this realization, a new urgency emerged. Astronomers, space agencies, and engineers began to ask the same question: how can humanity be ready next time? For there will be a next time. The solar system is not an isolated island. It is a crossroads open to fragments from the galaxy, and with each year, the probability of another interstellar visitor grows. The first line of preparation is the eye. To see such visitors earlier, wider, deeper, the most ambitious step lies in the mountains of northern Chile, where the Vera C. Rubin Observatory nears completion. Its vast mirror, 8.4 meters across, will scan the entire sky every few nights, recording the faintest moving lights with unparalleled precision. Unlike previous surveys, which searched only in narrow swaths, Rubin will map the heavens in sweeping detail, building a living movie of the sky. For interstellar objects, this means discovery not weeks before they vanish, but months, even years in advance. A faint point of light moving just slightly against the background stars will be flagged by algorithms trained to recognize the telltale signs of something unbound to the sun. The hyperbolic trajectories that once shocked astronomers will, with Rubin, become identifiable much sooner. With early detection comes the possibility of action, but detection is only the beginning. To truly study an interstellar visitor, humanity must learn to pursue. The European Space Agency has already committed to a bold step with its Comet Interceptor mission. Scheduled for launch in the coming years, it will wait at a gravitational balance point near Earth, a sentinel prepared not for a known target, but for a surprise. When a new comet, or perhaps an interstellar traveler, is discovered, the interceptor will deploy, racing to meet it. Its instruments are designed to approach, to image, to analyze, to taste the chemistry of an object born beyond the solar system. It is a spacecraft built not for certainty, but for possibility. NASA has joined this effort in its own way, studying mission concepts that could one day intercept fast-moving objects. Some designs imagine fleets of small, agile spacecraft, ready to launch on short notice. Others propose pre-positioned explorers, waiting in orbit or at Lagrange points, fueled and silent until their quarry is found. The idea is simple yet revolutionary. Humanity must be ready to chase what it does not yet know exists. To succeed, these missions must rely on speed, precision, and adaptability. Interstellar objects move faster than anything native to the solar system. Their windows of observation are short. Their trajectories are fleeting. To meet them, spacecraft must launch quickly, adjust course with agility, and endure the harsh light of the inner sun. The challenge is immense, but the reward is greater, a chance to hold in instruments the dust of another star, to read in real time the chemistry of a world not our own. Spectroscopy will be the key. With it, the fingerprints of molecules can be traced across light years. Water, carbon dioxide, ammonia, methane, each leaves its mark in the wavelengths of reflected sunlight. From these signatures, scientists can reconstruct the environment in which the body formed. Was it born near a young star rich in heat and metals, or in the cold, distant reaches of a planetary system where ices grew thick and fragile? Such measurements would turn speculation into knowledge, lifting interstellar objects out of mystery and into comparative science. Trajectory tracking is equally vital. By following the precise path of an object, scientists can rewind its orbit through space, tracing its origin to a region of the galaxy, perhaps even to a family of stars. Though the exact parent may remain unknown, the context will grow clearer. Each trajectory adds another thread to the map of galactic dynamics, showing how systems exchange material, how debris flows through the Milky Way like rivers through a continent. To achieve this, the science must be global. No single telescope, no single mission can capture the whole story. Networks of observatories must share data instantly. Algorithms must scan continuously. Agencies must cooperate across borders, not as rivals, but as participants in a common endeavor. For the next visitor will not wait for politics. It will arrive without warning on its own clock, indifferent to human divisions. This recognition has sparked what some describe as a race not of nations but of capability. Which instruments will first catch the faint signal? Which spacecraft will be ready to launch? Which team will read the chemistry of another star's fragment with the highest clarity? Yet unlike the space races of the 20th century, this is not about flags or borders. It is about readiness, about learning to listen more carefully to the galaxy itself. For interstellar objects are no longer theory. They are reality. Oumuamua, Borisov, Atlas, 3 voices in just a few years. And if 3 have been noticed, there must be more. Countless more. The Rubin Observatory alone is expected to reveal dozens, perhaps hundreds, over the coming decades. Each one will be a messenger. Each one will be an opportunity. And with each one, humanity must be ready not only to observe, but to reach, to study, to understand. This urgency carries with it a sense of destiny. For the first time, humanity stands at the threshold of interacting not with its own solar system, but with the wider galaxy. The tools being built today are not just telescopes and spacecraft. They are bridges. Bridges between stars, between histories, between chemistries. To study an interstellar object is to hold in human hands the memory of another sun, the dust of another world. And so, across mountaintops and laboratories, across agencies and nations, the work continues. Mirrors are polished. Algorithms are trained. Spacecraft are designed to sleep in silence until the moment comes. The next fragment may arrive tomorrow or decades from now. But when it does, humanity will be watching with sharper eyes and faster hands. The story of 3i Atlas was one of missed opportunity, of a messenger glimpsed and then lost. The story of tomorrow may be different. For tomorrow, the tools will be ready. The cosmos will send another fragment, as it always does, and this time humanity will answer. There are moments in science when the data dissolves, when the numbers and trajectories fade into the background, and what remains is something older, something deeper. The discovery of interstellar objects is one of those moments. For the first time in history, fragments from other suns have entered human skies. They came not as signals in radio frequencies, not as flashes of coded light, but as physical bodies, stones and ice and dust crossing into the solar system without invitation. Their presence is quiet, almost indifferent, and yet their symbolism is profound. The cosmos has begun sending messengers. I, Atlas, was one of them. It did not burn with spectacle. It did not thunder across the heavens. It came softly, a faint point of light among billions. It appeared and then dissolved, fragile and fleeting, leaving only a trace in the records of telescopes. But in that fragility lay something larger. It reminded humanity that Earth is not an island. It is part of a sea, And in that sea, currents from alien shores brush against its coasts. The question lingers, haunting in its simplicity. Was Atlas summoned? Not by intent, perhaps, but by inevitability. The cosmos is vast, and over cosmic time, fragments must wander. Their arrivals may be nothing more than chance, the mathematics of probability played out against the scale of billions of years. Yet chance does not make their presence less profound. It only deepens the mystery, for inevitability itself can feel like a kind of answer. Humanity has long searched the stars for life, for meaning, for signs that it is not alone. Radio telescopes scan the skies for whispers. Spacecraft carry golden records into the void, and yet even before any reply is heard, fragments arrive. Oumuamua, Borisov, Atlas. Messengers not of voice but of matter. They are not signals shaped in language, but letters written in the chemistry of alien worlds. Letters unread drifting across light years carried by silence. To encounter them is to feel the cosmos in motion. To see a body like Atlas is to glimpse the hidden dialogue of the galaxy. A dialogue not between civilizations, but between systems themselves. Stars throw fragments into space. Some fragments fall into new orbits. Some wander endlessly. Some crash into distant worlds. The galaxy is not static. It is porous, dynamic, alive with exchange. And Earth, with its oceans and mountains and civilizations, is caught in this current whether it wishes to be or not. The haunting possibility is that these fragments are already answering the search for life in ways too subtle to recognize. If interstellar comets carry organics, then they are carriers of potential, scattering the seeds of chemistry across star systems. Perhaps life does not arise in isolation, but is shared, nudged along by encounters like these. If so, then every interstellar visitor is more than a rock. It is a vessel of possibility, a reminder that the conditions for life are not bound to a single sun. Even without biology, the symbolism remains. Humanity is always asked if it is alone. The arrival of fragments from other stars is, in its own way, a reply. Not in language, not in intent, but in presence. The cosmos does not need to speak for its message to be felt. It delivers reminders in the form of wandering bodies, silent but undeniable. They say you are not isolated. The solar system is not closed. You are part of a larger whole. What is most humbling is how incomplete the understanding remains. Atlas dissolved before it could be fully known. Oumuamua departed too swiftly to be studied in detail. Borisov sped through with only a brief window of clarity. Each one is a letter opened only in part, its sentences broken, its meaning fragmented. They are communications humanity is not yet fluent enough to read, and perhaps that is the deeper truth. The universe has been speaking all along, not in words, but in fragments, in dust, in trajectories. Humanity is only now beginning to learn the language, a language written in orbital mechanics and spectral lines, in the faint signatures of ices sublimating under alien sunlight. To learn this language is to recognize that the cosmos has always been more open than imagined, that the boundaries between stars are thinner than believed. There is a quiet beauty in this. For if the universe is scattering fragments endlessly, then it is also scattering meaning, not in deliberate messages but in the raw materials of connection. Each interstellar object is an opportunity to listen more closely, to translate a little more of the cosmic dialogue. Each one is a step toward literacy in the language of the stars. The emotional weight of this realization is difficult to ignore. Humanity stands at a threshold. For the first time, it is not imagining contact. It is witnessing it, though not in the way it expected. The visitors are not ships or signals. They are broken shards, messengers of stone and ice, yet they are real. They are here, and they remind humanity that it is already part of a story larger than itself. In this light, the search for life becomes not only a search for voices, but a search for fragments. If the universe is filled with travelers like Atlas, then the seeds of connection are already being delivered. To find them, to study them, is to read the letters left unread for so long. And so the closing reflection is one of humility and anticipation. Atlas came and dissolved. It left no certainty, only mystery. Yet in its passing, it joined a growing chorus of reminders. The solar system is not alone. It is porous. It is touched by wanderers from forgotten stars. Perhaps one day, with sharper instruments and faster missions, humanity will read these messages fully. Perhaps one day, the chemistry of an interstellar object will reveal not only the story of its birth, but hints of a shared galactic narrative. Until then, the fragments remain what they are, Letters drifting in the dark, carried across light years, their meanings still hidden. And as they pass silently through the night sky, they ask humanity not to solve them instantly but to prepare for the day when the language of the stars can finally